We got two Bryston 4Bs here, but they look a little different. So, Mike, what's going on with them?
All right, I'll tell you about these. These came from movie theaters here in Chatham. They're about 40 years old. Yeah, 40. These are 80s products from Bryston, which is a great Canadian-make electronics company that make some of the most powerful amplifiers, especially back in the early 80s. There was nothing like them. And these sold back then. You'll see that these big commercial amplifiers have rack mounts, and they used to mount into racks in the studio theaters. They have quarter-inch jacks on them, you know, like on your guitars. Quarter-inch inputs. So we've added a few things. We took one of them. A gentleman had bought 5 of these. So this is a non-modified, original, untouched Bryston. And this one is the exact same year, but this one's been fully modified by Gilbert Young to perform as best it can. And there's actually a change to it in the way that it powers itself, so that it's much quieter and runs ice cold as far as the outputs go. These things can run very warm. They're very powerful. I think 250 watts per channel, something like that. You'll see 2 large transformers in this Bryston, one here, left and right. They're dual mono kind of setup, like this transformer powers this side of the amp, that transformer powers that side of the amp. Capacitance for each side are set on boards. This one actually was sent back to Bryston, and they put in 4 capacitors. These are 100-volt capacitors, quite large voltage because you're making a lot of power on this output. And they put up a circuit board. You see in here? Come on in, I'll show it to you. See back in the bottom, there's a circuit board at the bottom. So that circuit board is where these capacitors connect, and there's all kinds of wire that goes from the power rectifier through, and then the signal power comes up. Here, there's power here, and these are the left and right drive pre-boards. These are the line stages that are on the sides. You see this connector, Aaron? And there's like some 20 connections here. And this clips and slides on pins. And you know what a pin connector does? It's like this. It slides onto a pin. But a pin connector doesn't connect very well. It's kind of loosey over time. And let go, it gets dirt in there and air in the contact, and you only really have a couple of contact points. So there's those little things we saw. There was places we could change speed. We could change how much AC. The AC line you'll see down here, and there's a little red one way down. And it's quite small for the time. That was the one I'm wiggling on that screw. And that's your main 120. That's your big power. And if we want to have 500 watts moving through, there's your, look at this. That's your 500 watts through here and through all these pin connections. So there's lots of room for improvement here. So Angela-Gilbert there's a whole sheet, a list of things that were done here. So it's been completely rewired. And in that case, on this Bryston, get over here as best I can with this light so I can see it. Look here, Aaron. We've got our capacitors. You see now? No board. It's gone. So that little thin 7/1000th of copper, that would be very slow for the capacitors to fill in the holes in the music when the components need help, is now on Romex 14.2, like your same stuff that's in your wall. On beautiful, you'll see large 3-way built-up lead solder connections that don't drip. So all the metal is right where you need it to vector through all of that energy into the signal boards. You see the signal boards? Remember the pins up top here that were up top and over here? See, remember over here? See how they're all gone? And we wired directly to the board. And see now our big 120 and our power? It's on a great big 14 gauge. And it's direct to the board. So it's quick and it's quieter. And we're never going to have a bad contact, and we're never going to lose detail. The signal path also 3 times the thickness of the original. And the board's soldered joint to joint. When we're going to these outputs, you'll see an output panel here. You'll see an output panel over here. And all of these are wired direct and beautiful solder joints on each. There's been a few other small changes to the amplifier, because back in the 70s, they put in really kind of cheesy power cords back then. They were big, but they were just big because they had big insulation cotton in them, and they didn't have big copper in the windings. Now we can buy, as you see, we put an IEC power cord in here, removable chassis power plug, so you can upgrade it. Instead of the 1/4-inch lock terminals, those are for your, like, it looks like a headphone jack only, but mono instead of stereo, so one left, one right. We put our CAs in the chassis. We use the fuse inside instead of outside. That's up. These are now not used because we've got, they're little tin things with thin metal, and there's two. We can achieve that with one great mains fuse for both, because we've joined these two transformers together. So now instead of dual mono, we have the same power of the two transformers, but they're synchronized now. They're in harmony together when they work the left and right channel. So we gain a solidity and a quietness that you wouldn't otherwise get if you didn't join these transformers. So all of that with this capacitance now wired, we're a lot faster. There is a little more capacitance here than is in the original amp. And capacitance is like gas can voltage, for lack of a better word. It's energy. So on top of that, we've added our usual FCF jack down here, and you'll see that those orange leads come in right here. Now those orange leads go directly to the 14 gauge copper. So at this voltage that we have in here, 100 volts, we can add 100 or 200,000 microfarads of capacitance and really add to the sound quality. But we can do something else that was innovation by Gilbert Young. So we removed all the direct, we've direct soldered, we've replaced with 18 gauge and 14 gauge copper wire, we've installed FCF, reconnected the output directly to the terminal binding post. So the output used to go through boards and now it goes straight to these jacks. That's huge in output as well. We've bypassed rear bridge mode board and kept the bridge mode function only, which is basically, instead of going through that whole circuit board, we're going right from the rectifier bridge to our power, which is how you're supposed to do it. We, IC cord I told you about, replaced the original power switch with a 20 amp rocker switch. So there's a power switch in there that was part of the reason that this amplifier failed, because it was frail and it was old. It was a little under designed for the power that's going to use when you start this amplifier up. And if we're going to add a lot of energy, we need a good strong mains connection. We've replaced the inner output stage between the output transistors from 20 gauge to 16. So our 500 watts that comes through here now goes through a lot bigger pipe. We've bypassed the thermal protection inside of it, removed and bypassed all the edge connectors with direct soldering, which I showed you, those 21 pin connectors. And this sounds completely different than this. Not only that, Angela came up with another idea that we were going to put a 66 volt transformer where I can plug for a test this power cord into the wall, our mains power cord, and this gets in front of these two transformers and drops the rail voltage that this operates, instead of 100 volts down to 45 volts. And we all know with a sine wave and voltage, the bigger the wave is the bigger voltage. So our noise floor goes up. If we have 100, that's our noise potential. If we have 40, that's our noise potential. So we've got a lot less noise potential. We've got joint synchronized transformers. And now my capacitance, if I add on to this, I can add 300,000 or 400,000 more, because the voltage is lower. The capacitance that we buy, the capacitor to put on can be much larger and give you more energy, because at music, the very first 20 milliseconds, this pluck of the instrument, the start of the music, first step, how fast it is your dynamics and your impacts and how much it's going to be real sounding, as opposed to sound like a stereo system. So that's quite a mod, isn't it? It's amazing how many things we're done. It basically has turned into a uber high-end product with very few mistakes now, and it should last a lifetime.